So this is the file that Peter sent over. I'm just going to go into my perspective view and I'll shade it so we can take a look. So this is the this is the file here, and you can see the seams that Peter's added, and those we're going to split those apart and create the flat file from this. So the first thing I'm going to do, because this is a single file, as Peter had mentioned, he joined everything. So the first thing I have to do is explode that into those 5 patches. What I do over here, I have my explode icon, or I can actually type explode up here, but I'll just use this. And now, if I look, I will have separate patches for all these pieces. ExactFlat, this is ExactFlat in Rhino. So we have 2 versions, one in Rhino and one that runs in SolidWorks. I'm using the Rhino version right now. And in the Rhino version, we have our meshing tools, we have our flattening tools, and we have our highlight tools. So our meshing tools, just as Peter showed, this is a fairly dense mesh. It's a nice mesh. What we're going to do is we're going to adaptively remesh this, and what the software, what ExactFlat's going to do is take this mesh and decimate it down to a mesh size that's easy to handle for ExactFlat, but it's not going to lose any fidelity of the mesh. So the first thing I'm going to do is weld the vertices. So just typing in weld vertices. That's what I like about Rhino. If I can't remember where the icon is, I can actually just type in type it in. So I'm going to select this mesh. I'm going to weld the vertices here, and let me try that again. I think I spelled weld vertices wrong. There we go. Okay, so we'll select these and just hit enter on our keyboard, and now all these vertices are welded. The next thing I want to do is, I said, we'll adaptively remesh this. So I'm going to, here's our meshing. We have a uniform remesher and an adaptive remesher. I'm going to select the adaptive remesher. I'm going to select the headrest. I'm going to hit enter on my keyboard. And in a second, we'll have my adaptive remesh settings. So these are the pieces that Peter's created. The software has decided this is the best defaults for this headrest, and I'm just going to hit start. And in a second, you'll see what it's going to do. It's going to recreate this mesh, or regenerate the mesh. So it's going to disappear for a second and do a few calculations, and in a couple more seconds, we should see the headrest reappear. So the mesh has been remeshed, and you can see it's a lot less dense. I'm just going to hit OK here, and I'll shade this again so we can see that we haven't lost any of the fidelity in the mesh, and we still have the split lines. And the reason I reduced the mesh is that ExactFlat flattens the polygons, so the mesh itself is made up of a bunch of triangles. So if you have the less number of triangles you have, the faster the flattener will go. So what I'm going to do is I'm going to flatten this now. So I'll go into my next set of tools, which is my flattening tools, and I'm going to select this first icon, which is select pieces for flattening. And I'll just highlight the mesh again and hit enter. And as soon as I did that, if you look over here in my layers, I'll just open this up a little bit, I have a pattern layer and a model layer. So the pattern layer is what I'm going to be working on. So I'll make that the active layer, and I'm going to turn off my other 2 layers. And I'm just going to zoom to extend so we can see this. And I'm going to shade it because ExactFlat runs like an FEA analysis, and it's going to show the strain on the seat, or on the headrest. So once I turn this on, you can see the strain on the edges. Now, ExactFlat's a 2-step flattener. The first step gives us what we call a projected flat, and that's what we're looking at now. The second step's when I go in and I optimize. So I'm going to select the material that the headrest is made out of and flatten based on that material type. And that's one of the things that makes this flattener so unique and so accurate, is that you actually can address the material properties by, so if this was a leather headrest, it's going to flatten the material as if it was a leather. If it was nylon, it'd flatten it based on how nylon flattens. The other thing I should show before we get too much further into this is if I go into my ExactFlat options, the legend here shows the different strain. So this red is about over 20% strain. Sag shows up as a gray, and complete flat is white. So if there's no strain on the part, it's white. And we want to take all the stress or strain out of the material, so when we sew it back into the 3D shape, we're not having spots where the fabric would be ripping apart, which would not be good. The other thing is, if I go to my DXF export, this is where I put my seam allowance, and the headrest is in metric, it's in millimeters, so I'm going to put a 6mm seam on the part. So when I flatten it, it's going to add a 6mm seam. I'll just hit OK here. All right, so let's get into the rest of the flattening routine. So now I'm going to go over here. One thing that we do also have, other than decimating the mesh so it runs faster, I can also use one of our pre-flatteners to get the majority of the strain out of the part, and then I'll optimize, and this will speed things up a little bit, even a little bit faster. So if I click this is our smart fracture tool, and when I hit a piece, you'll see it actually reduces the strain and gets it almost to 100%. Well, you can actually sew that up, but I want to show the optimization part of this as well. So here's our 5 flat pattern pieces. If I go to my optimizer, which is the second tool here, and I just select all these pieces, rectangle select them, hit enter on my keyboard, it's going to bring up this spring setting and material settings. And this is where we have our material library of materials. Now the software comes with, I think it's about 80 different material types. We do have a lab that we can test materials, so if you have a specific material that you like tested, we can test it for you. The cost is about $30, and it takes about 3 to 5 business days to get the results. Anyway, I'm just going to go ahead and use this cotton, and I'm going to hit OK here, and this is going to bring up our spring status tool. And it'll go through, and what it's doing is it's going through, it's applied that material that I selected, which was cotton in this case, and it's going to go through and it's going to flatten these pieces based on how cotton would flatten. As I said, the part was pretty much production ready when I used my pre-flattener, but I'm just going to apply the cotton material and we'll see if there's any changes. Maybe a little bit, but not much. And that's our last piece, so we're just about done. Now, I did a test just before we got online, and to create a flat pattern for the headrest took me about 3.5 minutes. So I can do this in about 3.5 minutes. And then when I used to do work in the automotive industry for doing car seats and seating, basically to come out with a pattern for an F-150 truck would take about 28 days because we go through clay modeling and draping and taping, and that's kind of usual for the traditional way of patterning. But using the peel scanner and ExactFlat, this headrest, as I said, under an hour you would have patterns, and these patterns will fit perfectly on the piece.